Hello and welcome to another episode of Curiosity Labs Between Two Nerds, where if you've seen us before, you'll know that every week we invite a small human being to sit between us and have a little chat about science. Hopefully you've seen us before, so you'll know the format. If you are watching this on YouTube, please don't forget to give us a like and a subscribe. It means a lot. And if there's anything you do or don't like in particular, don't hesitate to leave a comment. We love those comments. If you are in need of your eyeballs for some other purpose, you can find us on all the major podcast channels. And if you are listening to us right now and would like to know what we look like for whatever reason, check us out on YouTube on Between Two Nerds. I think it's YouTube /Between Two Nerds. So, straight on, this week's tiny-ish human being is...
Zaraar, and I'm 8 years old.
Zaraar, and you are 8 years old. High five.
Hi, Zaraar. How are you?
Good.
Good? Okay. And you know the nerds, I'm Mo.
And I'm Eugene.
Okay, Zaraar, what would you like to talk about?
If the Earth is so, huge, then why is the magnetism on it so small?
Because the
weak.
Earth isn't huge.
Yeah.
Okay,
Next
well,
question.
to what-
I'm just joking. So if the
That's
Earth
a big
is...
question.
If the Earth is big, why isn't the magnetic field of the Earth stronger?
Yeah.
As in, why aren't we all getting pulled down? Well, we are, in a way. Why isn't all metal getting attracted to it?
Stuck to the ground.
Yeah?
We'd be stuck.
Yeah.
But we're not.
Yes, the Earth's magnetic field is really weak. It's weaker than a fridge magnet. And when you measure the flux, in Teslas and Gauss, I can't remember what it's called now. Yeah, the magnetic field strength, it is a lot weaker than a fridge magnet. But do you know how you make magnets?
Not at all.
No? Okay. Well,
Do you know what do you need to make a magnet? There's different ways we can make magnets. You ever played with magnets?
Yes.
There's a metal that comes up. If you're ever at school talking about magnets, if you're ever reading about magnets, there is a metal that comes up a lot in conversation. Do you know which metal it is? It's a super famous heavy metal.
Heavy metal. Gold.
Gold? No.
Silver.
there's
No.
a superhero named after it.
It's not so shiny. Superhero can fly, wears a red suit, presumably made of the stuff, but I don't think it
Yeah,
is.
I don't think so.
I've never heard of him.
Yeah, you know.
No. Iron Man.
Great shout, Iron Man.
He's not made of iron.
No, I've only
but
just
that's
thought
what
about
it's
that.
called.
That's
Then there's also Man of Steel, Superman, and that's steel iron. Yeah.
It's made of steel, not iron.
Yeah, but steel
more
is
likely-
made from iron.
He's more likely to
Anyway.
be using steel than iron,
Yeah.
in all fairness. Should be
Yeah.
steel, man.
Yes. Okay. Anyway.
It's important.
Yeah.
So iron, massively. Have you come across iron?
Yes.
Yeah.
Now, our planet, you need iron to make a magnet, or iron is hugely important.
Yeah.
Now, do you think there's anything on our planet made of iron?
Parts of this building.
Parts of this, but
Yeah,
absolutely.
yeah.
So we find a bunch of iron on the surface of our planet, but there's somewhere where there's loads and loads and loads of iron, and it's not on the surface of the planet. Where do you think it might be?
A garbage dump.
That's such a good answer.
That's so good.
But that is on the surface. We could dig a big hole. Are you thinking about a landfill? Dig a hole in the ground, fill it full of iron,
Yeah, kind of.
cover it up again, and there we have the Earth's magnetic field. No, go deeper. What shape is the Earth?
It's a circle. Well, technically like a circle.
Is it? Yes, sort of
Like a tomato.
spherical.
Yeah.
Yeah, it is more like a tomato. And we live where? On the outside?
The crust.
Good.
Very good. So now let's dig through the crust. Where do we end up?
I haven't done this yet.
Yeah, don't worry.
So inside, we dig through the crust, we're in this massive kind of ocean of hot, which is molten rock. And have you heard of magma?
Mantle.
Yeah, the mantle.
Yeah.
So you do know
You
it.
do, but you haven't done this and you know it.
And then what's underneath the mantle?
I don't know.
No.
There's a big ball in the middle.
The core.
Yeah.
See,
you do know
confidence.
it. Confidence.
Say what you know, because you know it all.
Yeah.
Now, what do you think that core's made of?
Hot rock.
No, let's go back to the start of my wanging on
The
about
metal.
the Earth.
Metal. Okay.
Which metal do you think it might be?
Iron.
Yeah, there you go. Mostly iron, yeah.
very good.
Yeah, so the core's got 2 bits, inner core and outer core. The inner core is solid and almost all iron. Then the outer core is iron, nickel. I think in the previous podcast I said cobalt, so that's wrong. It's got some other stuff. I think it's sulfur and something else.
Did anyone call you out?
No, I just I checked it after I said it, and I was like, oh, that's not right. Yeah, so it's iron, nickel, mostly iron though. And the outer core is liquid, okay? So in the the outer core, you have iron, and iron's a conductor of electricity, right? Do you know what a conductor
It
is?
allows electricity to flow through it.
Very good.
Can you name me any other conductors?
Water,
Good, yeah.
Yeah. That's a good one to know, that. That's a
Yes.
really good one to know.
iron, which is the
Yeah,
same
iron,
as
there you
the-
go. Copper, is things. Gold, like you said before, is actually a really good conductor as well. But
Makes
so it's because so inside the inner core, because of this heat, you have the same thing. The reason why we have currents in the sea, because hot water rises, cold water sinks, new water takes its place, and because of that, the same thing happens in the core as well, in the inner core. So like hotter bits of iron, let's say, are floating up, colder stuff sinks down, and they keep swapping places, and this causes currents inside the outer core.
Or your oven.
Yeah, or in your oven, yeah, because they have convection ovens. So that movement of this conductor creates electric currents. Those electric currents, right, create magnetism, but that magnetism feeds back and causes more electricity, which causes more magnetism, and so on, until you get the Earth's magnetic field, which isn't very strong as well, because these currents are flowing in all random directions, right? For like a magnet, so the thing that causes magnetism is how electrons, do you know electrons, right? It's part of an atom, about how they spin, their quantum spin, right? Now, if in a material, all the electrons inside that are spinning in pretty much the same direction, that's when you get a magnet. The more that those spins are spinning in the same direction, the stronger the magnetic field.
Have you ever done the little experiment with a needle that has no
make a
magnetism,
compass,
and then you get the magnet and you rub the needle? Now, it's important. What's important when you're rubbing that needle?
that it gets electric charge.
Do you rub it backwards and forwards?
Yeah. Oh yeah, you have to do it like once.
You have to,
Yeah.
exactly. You have to keep rubbing it in the same direction.
Yeah.
And that's all about getting the electrons in that needle to be spinning in the same direction.
Yeah.
And then it makes it magnetic. So
Yeah.
that's why when you're doing that experiment, you have to rub it in the one direction only.
Yeah. And because like in the core, it's this ocean of different currents flowing in lots of different directions. So it's not all uniform. So that's why the magnetic field isn't very strong. But the cool fact, the magnetic field around the Earth isn't uniform. Like it's not like how you have with the bar magnet. You've done the thing with the iron filings,
Yeah.
right?
No,
And
no,
you
no,
get,
not yet.
no? Okay, so you get these magnetic field lines around, so this force field,
Yeah.
right? But there are bits where the force field is weaker in some parts than in other parts. There's one particular place in South Atlantic. Okay, so the Atlantic Ocean, the south part, right?
The bottom
Around,
bit.
kind of over South America, actually. The magnetic field is weaker there. And that's a problem because, well, the magnetic field is very important. The Earth's magnetic field is very important. Okay, we call it a magnetosphere, kind of like an atmosphere, magnetosphere, right? Because it shields us from these dangerous, highly charged particles and solar wind coming off the sun that could harm living things. So it's very important. And it's that, though, how when those particles come in, hit the magnetosphere, they get pushed, they get diverted towards the north and south pole, and then they hit the atmosphere there and cause the atmosphere to light up. And do you know what we
Aurora borealis.
Yeah, aurora borealis and aurora australis.
Yep.
Yeah.
The less popular one for some reason.
Yeah, so that's what causes that light show. Actually, by the way, the magnetic field is weakening.
Yes. And isn't that
And it's about,
switch?
magnetic fields, every so often in our history of the planet, magnetic fields switch. So the North Pole becomes the South Pole, and the South Pole becomes the North Pole.
That's weird.
We
And
probably won't
think-
change its name,
Yeah,
though.
yeah. We think it's imminent. Not imminent.
What is
It's going to happen quite soon. And it only happens every few 100,000 years that it happens. But it will happen. Probably
And
will
naturally,
happen
it's like the
soon.
millennium bug.
Oh, like
That's the
Y2K.
fear. So Google that, and you'll find lots of people saying, "Well, that's
Yeah.
going to cause us major, major problems." I don't think it will.
Do you have another question?
Yeah, is there like an electromagnetic field on other planets?
Good. I like you called it electromagnetic field.
Very
good. Yeah. Yeah, there are. Yeah.
I meant to say magnetic.
Yep, All right.
We accidentally added
Yeah.
a great word.
So the magnetic field, quite a few planets have it. The gas giants all have very strong magnetic fields. You know what the gas giants are?
Yeah.
Yeah, go on then.
I completely forgot though.
The biggest
do?
one. What's the big one?
What's the biggest planet?
Jupiter,
Good.
Very good.
Second biggest, most beautiful planet.
Venus.
I think Neptune's pretty beautiful.
I mean,
But-
if you could see through a telescope,
But no, it is that you're right.
big ring.
The big ringy.
Super
thing.
famous.
Neptune.
The
That's
other
a
one,
s-
It has a ring though.
even more
Is it?
famous
No,
for its
big,
rings.
Big ring.
Big ring.
Which planet's famous for its ring?
Saturn.
Yeah, there you go.
Isn't that ring? So if you were on that ring, so if my hand,
It's
if you're on the podcast right now, then you'd have to imagine my hand. Isn't it something like 100,000 kilometers in width,
Yeah.
that ring around? So it's
But
enormous.
it's incredibly thin.
Yeah, yeah.
Yeah. It's a very thin layer.
Isn't it made of
Mostly, yeah.
Isn't like the rings made of like satellite dust things?
Yeah, so there's some dust, rock, ice as well.
Nice.
Yeah.
Loads of ice.
Yep. And there are moons in Saturn, on Saturn's rings. There are moons inside the rings. And Saturn now has the most moons of any
70
planet.
plus.
Okay.
And the rings are formed by the gravitational pulls and pushes and stuff of all of these moons. Anyway.
And it has an
And then
electromagnetic
there's
field.
the next one's Uranus. So those are our gas giants, sort
Yeah.
of. Yeah. So they all have strong magnetic fields. Mars doesn't, and Venus doesn't.
Did Mars? Don't we think that it once did?
I don't know.
Well, we're
It
finding
could have.
out.
Well, I
We're
mean, if
heading
it
there.
had life,
Yeah, exactly.
then possibly. So Mars doesn't, which is a big problem. If we go to Mars, it not having a magnetic field will be quite dangerous for us humans. Okay, and Venus doesn't, and Mercury has a weak magnetic field, I believe. Yeah, there you go. Yeah, so it's not uncommon. Of the 8 planets in our
Yeah.
solar system, 6 out of 8.
Our tiny sample.
Yeah.
How many planets do you think there are in our galaxy?
I don't know.
Exactly.
No, it's more than 8.
It's way more than 8. It's at least 10.
Yeah.
Billions, hundreds of billions.
Yeah.
Billions.
Yeah.
Yeah. I think it's like, so you can do the math on this. So in our galaxy, about 100 billion stars-ish, right? Each star on average, possibly 4, let's say 4 planets. So 400 billion planets, possibly in our galaxy. And then there's all the other galaxies in the universe,
Which there's loads.
I've heard. Cool?
Yes.
Did you enjoy that?
Yes, completely.
Yep. Good.
Awesome.
Awesome. Great questions. Thank you for coming, Zaraar.
High five.
Okay.
Right.
And you want to just wave at that
Big
camera?
wave to the camera. Thank you very much for joining us again. Do leave a comment if you've got a comment to leave. Like us, subscribe to us, hit the bell for us, rate us. Do whatever, anything. All the
If
options.
you like what you're listening or watching, please let us know. And if you have any
don't-
questions, did you say that part?
No, yeah, that's a good point. If there's something you'd like us to discuss that we haven't yet discussed, I mean, it's early days for this podcast, but again, drop us a comment. We do look at them all. We do reply to nearly all of them, and we do enjoy nearly all of them. Correct us if we're wrong, start the debate. But yeah, anything you'd like us to discuss, just let us know.
Well, thank you. Bye.
Thank you. Now wave.
Bye.